Hello friends, today we will see this part and today we will see phase mill mid-pass operation in NXCAM. So I have this solid model and if you will see this is hollow from bottom side and now click here application and let's go to manufacturing and the manufacturing interface will enable now and now come to this role and here I am going to specify a role so that all the necessary option will come. So come to this advanced rule and apply. This is for manufacturing planner and okay. So advanced role will enable and all the related option will enable. And here first I am going to define my workpiece because in workpiece we need to define three things as we have discussed in previous video. A geometry, a workpiece is a combination of geometry of reference part. This is my reference part and if for this case I am not going to use any blank, so leave it, and any fixture, any vise, any clamp, we don't have any additional uh, part, so I am not using that clamp or fixture as a check, so leave it and click OK. Now second thing we need to consider about the tool. For this operation I am going to use a bigger tool and this tool is a 65 mm diameter, right? So that we can properly understand this option I am using a little bit bigger tool. Here come to this, if you will see here we have MCS. MCS is stand for machine coordinate system. If you want to move this, double click over this MCS main and you can drag it and make sure your Z will be in tool direction. So tool will come from this Z direction. So I have checked it properly. Now I want to apply this operation on this outer face which is a planner. Click here for new operation and you can see this is mill planner. So we use mill planner operations for planar geometry which is flat. We cannot use this planar operation on a taper face, on a circular or cylindrical face. These all operations work only for the planar geometry. So in this case we have this all planar faces. If you will rotate it here again we have this flat geometry. This is not the flat, so on this taper face we cannot apply any operation from this planar. Okay, now the program we need to define some locations for this tool path. So first operation is this face mill mid pass. This operation will work on a specific planar surface and the mid of that surface. We use this operation for roughing to cut a floor and we can also control the distance between the walls and tool. So we can use this face mill mid pass. So select this mid pass and tool is already selected and this workpiece is my working geometry and this is roughing method. Here first select the cutting area, so my cutting area is this one. Okay, and now I am just generating this tool path and let us see what is the result. Okay, now verify this and replay and see the tool path is working for this face and it is avoiding the ribs. Okay, why this is doing like this? Come to this avoidance and here you will find This option is avoidance and the tool is avoiding the gauge. So it is degauge by default. If you want this none option, if you don't want to check this collision or gauging, you can select none. It means tool will not detect any collision. It will generate the tool path whether it is coming inside the workpiece. See here, it is coming inside the ribs. See, right? It is going inside the part. So it is not properly. So this degauge will avoid the gauging. And here report collision. So if you will generate it, it will show you the tool is creating some gauge on specific areas. Okay. And here we have one more option, and that is trim. Trim means it will generate tool path where it is safe. If it is creating any gauge, it will leave that portion. And see, a smaller tool path, it is retract. Again smaller tool path, it will retract. Again small portion and retract, and so on. Right? Okay. But I don't want like this. Just select this degauge. Select this and come to this main, and here we have some more option. If you want to define any stock on this face, so we can enter the value. So right now it is working as a finishing operation, and here we have this offset, pattern offset. If you want to offset this cutting tool path, so we can enter the value like 20 and generate, and you can see the tool path will offset 20 mm outside. Now see this, the tool path is working as a anti-clockwise, sorry, clockwise. Now I want anti-clockwise, so okay, and select this reverse direction. So tool path will work in reverse direction, and the tool path is, see, this tool path is the middle of this tool. That's why this is middle pass, and you can offset this middle pass by entering the offset value. If you don't want, just put the 0. And this extension will not work here, but here we have one more option. This is convex full. If you want to simplify your geometry, so toolpath will work as a simplified geometry of selected surface, and it will generate the toolpath. Right? Now see, okay, and okay, don't want this reverse direction, just skip and generate this again. We will cover all the option step by step, but at the beginning I'm just using the minimum options so that you can learn it properly and you can start your tool path easily. Thank you for watching. See you in next lecture. Hello friends, today we will see face milling zigzag. So here we have one part. So first of all, I'm going to define a workpiece. So create workpiece and select a workpiece. And the location of this workpiece must be under this MCS mill. Okay. Here, this is my part. Select this part. And for blank, I am using bounding block. Right. If you will see, we have we don't have any margin on the top of this face, so this time I'm increasing this by 0.2 inch and change this to, because the position is shift in bottom side but I want on top, so enter this value 0.2 on this G positive direction. I don't want to display, so disable this and okay. Again okay. So workpiece is defined, and you will find a tool which is already defined in this file, and I will share this file with you so that you can practice it. Now click here, and the option is face milling zigzag. For face milling zigzag, we use zigzag pattern for finishing a face. Basically, this is a face milling, and we can use zigzag in any direction so that we can cut according to the part angle, right? So this is the way, straight or on a particular angle, and we need to define blank thickness, and the result will come. Let's see with this example. Select this option, select the workpiece, okay, and here you will see specify cut area, and my cut area is this face. This is the top face. So I have selected this, okay, and here you can see the stock is still there. So I want to do the finish operation and say I want zigzag, and let's see with this standard parameter, and click here and see in wireframe. Come to this 3D dynamic, and let's see, it is not okay, but we will change it. Now the 0.2 mm material is cutting in a single depth of cut, so I am going to use 0.1 for this. Still it is cutting in single pass, whereas it should be work in two pass, in two level. So here come to this containment and define the thickness of material on this face. It is 0.2. Generate. Again see this. Now the first one, again the second one. Okay. If you want to define angle, so here cut angle you can define. Now generate. See, the tool path will work at an angle of 45 degree, or which we have specified. Okay. Here you can see we are using pattern containment as convex hull. This will work according to the selected face. Whereas if you will select this minimum box, so it will create a minimum box around the selected surface. If we are using 45, so this is a selected minimum box. Generate, same result will come. Whereas if you will keep this 0 degree, then this will be the result, and the box will be the same. But I want to generate toolpath for complete component. Then we need to change this from thickness to blank geometry, because this is my first operation, so I can use this blank geometry, so it will finish. Now generate, come to this, and from 3D, now it is okay. If you want to apply any angle, select this and see, now it is working like this. Okay, for our example this will not work, so make it 0. And one more thing, you can also use zig. Say this, it is coming back, now coming back, so it takes much time as compared to zigzag. Whereas in zigzag, it is start from this point and it is ending here, and again tool will retract and it will come to first point, right? It is working like this. Now I want to change this. Okay, and come to this strategy, and here you will find this cut order between label. Maintain, it means it will start from a first point and it will end on second point. Again it will come to first point, then it will start. Whereas if you will select alternate, so it will start from first and from second point it will come back. See this? Okay, 3D dynamic. So hope you understand this properly. If you have any query, you can comment me. You can text me. Thank you for watching. Have a nice day.